Ever wonder why seeing something work a few times isn't enough to know if it's actually reliable, for the long haul?
Yeah, for sure. It's something we all kind of grapple with, I think.
Well, today we're diving deep into that with this Coup Research article, Why Probability for Reliability Evaluation. It really gets into why just a handful of good results don't guarantee long-term dependability, especially when you're using something repeatedly.
Sounds intriguing.
So let's unpack this. Why is probability so crucial when we're talking about how reliable something will be over many uses?
Well, the key takeaway here, I think, is that probability lets us see beyond just those isolated wins or fails,
Mm.
right? It's not about predicting a single event, but revealing the underlying trends over many repetitions.
So instead of just looking at whether a new app works for like five people.
Exactly. It's about understanding how it'll perform when thousands are using it all at once, with different internet speeds and everything.
Gotcha. So it's about seeing the bigger picture. The article uses the example of rolling a die. There's a 1 in 6 chance of getting a 1 it, which is about 16.6%.
Right, and that's a perfect example of why small-scale testing can be so misleading.
How so?
Well, if you only roll a die 100 times, you might get, say, 10 ones, or you might get 20. It's random.
So you're saying that those initial results might not reflect the true probability at all.
Exactly. The article highlights that with just 100 rolls, the actual percentage of ones could be anywhere from 11 to 23%. That's a huge margin of error.
Wow, so early success can be super deceiving.
Right.
So what happens when you roll the die more times? Does it get more accurate?
Absolutely. As you increase the rolls, those random variations start to even out, and the results get closer and closer to that expected 16.6%.
The more you do it, the closer you get to the real probability.
Precisely.
The data in the article is pretty convincing. Even with 10,000 rolls, you're still just around 16%. But at 100,000 or a million rolls, it gets super close to 16.6%.
I think it was within like 0.13%. Right.
Yeah. And with 5 million rolls, even closer.
It's amazing how the range of possible outcomes shrinks as the trials increase. With 100 rolls, the difference between the highest and lowest percentage of ones was like 12%.
Huge.
But with 100,000 rolls, that difference plummets to just 0.13%.
So basically, more trials equal a more stable and predictable outcome.
Exactly. It really highlights why a large number of trials is so crucial for accurate reliability evaluation.
Okay, so this all points to the fact that we need to think big when testing reliability.
Absolutely. Especially for systems or solutions designed for frequent use.
Because a small number of tests just won't cut it.
Right. Think about it. With only 100 trials, the potential for error is massive. The article mentions it could be off by as much as plus or minus 12%. But when you scale up to hundreds of thousands or even millions of repetitions, that error margin becomes almost negligible.
So probability gives us a much more reliable picture of how something performs over time, especially with repeated use.
It helps us filter out the noise of those early unpredictable results.
So whether we're talking about the quality of products or the stability of software, understanding the principle of repeated trials is essential.
It's about going beyond initial impressions and seeing how things hold up under real-world use.
This has been super insightful, and it leaves us with a really interesting question. How might understanding the importance of repeated trials change how you evaluate the dependability of the things you use every day? It's definitely something to ponder. Thanks for joining us for this deep dive into probability and reliability.
My pleasure.